Well, I'm going to putting together a little video to go through week 3 for the introduction to grades, GR 101, and the uh, sorry, I lost my train of thought. Anyway, we're going to start out with the grade define. This is a lot about we're getting ready to move into slope staking and some things like that. So it's time to start going through the calculations to find the percentage of rise or fall or the ratio of a slope. Uh, we will be using them both. As you'll see, first thing we'll cover is grade defined, then we'll go through the formulas, and then I'll show you, you probably may have found it, there is this little circle tool that we will talk about as we go through here. But let's just start out with grade define. And I threw this in here from another file that I had, and I've got up here before we start below. Below this is the below I'm talking about, is a 3D look at a slope. The rest of them will all be profiles. The rest of the time we'll just be looking at this like they just sliced up this piece of cheese or something. That's what we'll be looking at. We'll be looking at so it's the same objects, but this is what a slope would look like with stakes on it, just so you know. But our focus right now is just to go through and understand how to calculate uh, the uh, the ratio of slope, whether it's 2 to 1, 1.5 to 1, or the percentage of rise and fall, whether it's 2%, 3%. And usually slopes being a larger uh, um, than like a drain pipe is will have a small uh, uh, vertical distance. That's what I'm trying to say. Those highway slopes will, this will be your vertical distance right here as you look as we get on down through here. Like right here, see, we'll be looking at this is what we're looking at and these views here. So and that's just an explanation. I'll get to that in a minute. But this right here is your slope, as you can see right here. This is just trying to depict a real slope, so that everything, again, you'll have to imagine them going in 3 dimensions: vertical, horizontal, and depth, one like that. So the term grade has several meanings. When any equipment operator calls for grade, he or she's wanting to know where the elevation of the proposed grade is. Like we showed in basic stake marking, or especially in vertical measurement, we'd have a proposed grade. Well, that equipment operator wants to know where he is in relation to where that is, where he is in relation to where he needs to be. And you went through an exercise, I think, in having to use a hand level and determine whether it was cut or fill and how much. Hadn't had a chance to grade that yet, but we'll see. And we can go back over it if you guys had trouble. So that's what we're doing when we're calling for grade. Unless the operator can visualize the level or plane at which the cutting or filling must stop, the individual cannot hope to do the job. So he's got to have a pretty good idea of how much dirt he needs to bring in, for instance, or how much dirt he needs to take out. Uh, and it's telling it, okay, unless the operator can visualize the level or I just said that. For still another definition, the grading plane of a construction project line is the slope or numerical rate of ascent or descent of the line. The numerical rate is a percentage, and we will get to that. And it's a percentage and a ratio. This is the numerical rate for every 1 foot in this direction. It falls 1 foot in this. Like when you go down, out, this is 1 foot, 1 foot. So this is a 1-to-1. This one over here, it is horizontal. The horizontal is always on the left. So let's go in this direction, it'll be easy. For every 1.5 feet in this direction, it rises 1 foot. 1.5, 1 foot, 1.5, 1 foot. So it's a 1.5-to-1 slope. Here's a pretty common slope, a 2-to-1. For every direction, for every horizontal 2 feet, it will rise 1 foot. In carpentry, they call that run and rise, like steps. Same way they calculate steps is basically, except they use quarter inches instead of decimal equivalents. In expressing the slope ratio, remember that the number to the right of the colon is the vertical height, and the number of the ratio to the left of the colon refers to the horizontal. That is really not the way they're even showing it. 2 means it's 2 feet horizontal, and it is the number to the left as it being the horizontal, and the number to the right being the vertical. Where the rate of grade is expressed as a percentage. Now this is ratio. Don't forget, this is ratio. When it's expressed as a percentage, the rate of rise is computed for a horizontal, not slanted distance, not this distance. It's not even using this distance for a slope. It's using this distance for horizontal, not slant distance of 100 feet. Where the rate of grade is expressed as a percentage, the rate of rise is computed for a horizontal distance of 100 feet. And not just 100 feet, but that's the way you come up with this. This could be 300 foot, and this could be 3 foot, and you could still compute it. We will get into that. We don't do long division. This right here is 3 divided by 100, and we just don't get into any kind of long division. We use calculators. You would type in 3% is the same as 0.03. When you're dealing with percentage, you're dealing with the number 100. So when you have a decimal point, if you want to convert this and express it as a percentage instead of a decimal point, multiply it times 100, or just move the decimal to the left, to the right. So when we multiply it by 100, it would be 3%, as you see here. Now here's one that's 1.5% grade. Look, so move the decimal over 2 places, you would have 1.5. So that's the same as 1.5%. We can, when we're using percentage, let's stick to, we can use a whole amount of percentage. When we have a half of a percent, let's call it 1.5%. It's just for calculation reasons. It's just going to be easier and more sure in the long run. Now here's an actual situation. What you have is a profile view of an area where this clay pipe that they don't use that, that's bituminous or some kind of stuff they used, orange stuff they used a long time ago, and you just don't see that anymore, but nevertheless we can use it for this illustration. This profile is like, this is the land. This is the existing grade is right here. You see that? Okay. So this is the horizontal distance. This is survey speak right here. 6 plus 0 is the same thing as 600. So we always go from left to right. I say always, there may be exceptions. So from the beginning of the station of the project, which is 0 plus 0, we are at this point, we're 600 feet up, up, upgrade. I mean, up the road. It's not a road, but up plan. We're going to the right, so we're going up. All of your dimensions you'll see later on when they're going on percentage, when they're going in this direction, like the fall of this pipe. It's hard to pick out the pipe, but here is the bottom of the pipe. Here's the top of the pipe, and the pipe is going through these sections here. And notice that the horizontal distances are, look at this, from 600 to 700 we have 1, 2, so that's 650. That would be 700, that would be 750. You may have already had this in if you went through the certificate program, but it's not going to hurt to review. Look here at this. We're not counting here until this is the same things as 1,100 foot right here, 11 plus 0, just FYI stuff. The pipe, the length that this pipe is in the under the ground, the pipe's under the ground. Here's the top of the ground. The length of that pipe is 400 foot. So that's your horizontal distance, let's say. What we need to know is the vertical distance. In other words, what is the distance from here down or up to or down to here? Because see, it's falling from, what line am I on here? The bottom of the pipe is falling from 270, no, that's the wrong end. From 275 right here is where we're going to start. That's where the measurements start. 275, you see here's 270, here's 275, here's 280. So we're falling from 275 down to 270. So what's the vertical distance in that fall? I would say, can anybody tell me? But we can't see. Let me calculate it. We're going from 275 down to 270. So that's 5 foot here. That's a 5 foot fall over 400 feet. So the vertical distance is 5 foot, the horizontal distance is 4 foot. And with that, we can calculate the percent. This is a percent, believe it or not. It's just 0.008. Multiply that times 100, and what you have is 0.8%, 0.8% fall. That's what you have here. And where did this come from? I think they have different values, or maybe I got it wrong. Let's see. Well, let me check this right quick to see. Oh, I went too far. 270. That's like 272. I want to know where they got that 0.008. It's not going to tell me. So let's see if we can figure it out. We're not going to give up yet. Let's look again. Let's look at here it is. They say they're going more exact on the distance. Here it is, 271.8. So 271.8 would be, this would be 270. Right here, this would be 275. So 271.8 would be somewhere in here. And the other distance is 275. They started. So to calculate this, here it is up here. They take the vertical distance and divide it by the horizontal distance. Let's just look at this right here. And again, we're not going to do anything, but the vertical distance on this is approximately well, I still haven't found that yet. 3.2. Let me see. 271.8. 271.8 minus, where's the other one? 275. 275 equals 3.2. So their fall is 3.2. Here it is. They say it right here. 3.2 drop vertical by a distance of 400 foot. So go back up here. Well, don't go back up there. To find the percent grade, you would take, it's not going to go through that, and that's okay. We can do that. You would divide the vertical distance by the horizontal distance. So let's take 3.2 vertical distance here, vertical distance of 3.2 divided by the horizontal. 3.2 divided by 400 equals, guess what, 0.008. So the formula really, they haven't written it down here, but to find the percent fall or rise, you take the vertical distance of the fall or rise and you divide it by the horizontal distance. That's all they did here. If it was a 4/10 vertical distance for 4 feet, here's your percent right here. Let me calculate it. I didn't calculate that. So 0.4 divided by 400. Move it over. That would be be 0.1%, right on the money. 0.001. 0.008 is, these are all really close, but to be accurate, this one here is what we're looking at, 3.2. And this is just another example. What if it was 0.4 or 4/10 and 400 feet? Be just a little bit steeper. Of a fall. So just, if you got a pencil and paper, just put down percent grade equals vertical distance divided by horizontal distance. Write that down. That'll apply to any situation that you're dealing with the percent grade. Now, if I have any three of these components, the percent, 0.8 in this case. If I have that, if I know that, I can find this 400 feet. It's a little bit algebraic like, but I'm going to get to a point here where I can show you how to get around that, because remember, the formula is percent grade equals the vertical distance divided by the horizontal distance, right? Now, if I know that the horizontal distance is 400, if I know the vertical distance is 3.2, I divide 3.2 by 400, and that would give me this figure right here. If I know this figure, I can take, I don't want to get ahead of myself. That's what we're moving into. I have a tool that you can use in algebra, and I can't write on this thing. I don't have an annotating deal. So in algebra, when you have something like the percent grade that you don't know, and you have two knowns, all you got to do is whatever that function is. In our case, is divide the vertical by the other. Now, when you have just say you had a a, a vertical distance and a percent, you would have to get the numbers on one side and the percent on the other side. So the formula for that would be something like, well, it would be if it would be like the just a second, I'll have to write that down. If I don't know the percent grade and I know the vertical and I know the horizontal, I gotta, and I if I do know the percent grade, in this case 0.008, I don't know the vertical, but I know the horizontal is 400 feet. Unless the percent grade is 0.008, so the V has to stay where it is on top. And I wish I could illustrate this, but to move that 400 over to where the other number is 0.008, I have to change its function. So when it's like 0.008 equals V divided by 400, it would be V equals 400 times 0.008. Let's see how close I am with that. 400 times 0.008. Not enough zeros, right? 400 times 0.008. It equals 3.2. So it's hard to see with me just talking about that little old transition, putting numbers on one side, letters on the other side. That's an algebra thing. Fortunately or unfortunately, formulas are subject to some algebraic rules. So to get around this one, we'll be showing you something here as the video goes on to help you with that, so that it's basically foolproof. Let's see what's next. This is a little bit of what I was saying a while ago. Upstation, that's what it's called. I said upgrader. I don't know what I said, but these numbers up here are station numbers. That's what they're called. And this whole thing from here to here, this is 100, that's 100, 200, 300. See, that's 400 feet when you get to 1,000. And then the whole from 0000 is to here is 1,100 feet. Here is a really simple look at building a road. This road is, let's just say it's going to go, this is the top of the road. Here we had the top of the ground. That's existing grade, top of the ground. Here, let's call this dotted line existing grade. See it? This is the way the grade is before we build this smooth road in here. So there's going to be some cuts, there's going to be some little fills, and we'll get into this a little bit deeper as we go on. And this would be what you would look at to balance it. Now, this, if this was a cross section where the road went this way and this way, and this was a crown, it would be, and a lot of roads have a 2% crown on them. This one actually is showing a minus 3% on the other side. So let's just keep it as if it's the top of the road and it's going up and then it goes down. As I said before, when you are going rising, moving up station, it's a plus. When you're falling, right here, it's a plus percent. When you're falling going up station, and this is up station right there, when you're falling going up station, it's a minus percent. And we talked about that a little above there. So let me get back to the modules. Maybe a shortcut, but I'm going this way. And let's go to week 3. And we just went through grade defined. Let's see if we can get through this. This is when we really get into the percentages. Where all that writing, that's down here at the end. Let me, I kind of want you to not even look at this thing right here where my cursor is. This is that, I don't know what to call that thing. But remember earlier, we were talking about, let's say you know 2 of the three things you know. Let's say that you know, where's their little formula? There, here, let's stay right here. The horizontal distance equals the ratio times the vertical. The vertical distance, this is the main formula I want you to know. In finding a slope ratio, that's what we're doing right here, slope ratios, not percentage. We'll do that here in a minute. But the formula to find a ratio is ratio equals horizontal divided by vertical. Now they're showing you different ways of moving things around where that you know, and the vertical equals horizontal over ratio. So if you had this carried around with you in your pocket, all of these different ways to look at this, that would be one thing. But what if you had a tool that you could just plug in things? Let's say you have a slope that's, where's a good slope? That's what these, let's say you had a 2-to-1 slope that had a, let's say, an 8-foot horizontal distance. You got a 2-to-1 slope that has an 8-foot horizontal distance. You don't know the vertical distance. So instead of remembering how to move these things around, the example I got is 2-to-1 slope and a 8-foot horizontal distance. That's what I said. So we need to find the vertical, and this is the way to do it. But look at this circle. All of this stays the same no matter what these variables are. In this case, slope ratio was 2-to-1. You would put 2 right here. Horizontal, you would put 8. And then look at this little deal here. 8 divided by 2 equals what? 4. That would give you the vertical distance. And when your horizontal is 8 and your vertical is 4, your ratio's going to be 2. This is going to be in your, if you haven't came to it, it's a printable version of both slope ratio circle and percent circle. This little guy here is, I find it very not useful. It may be to you. What if you got, this tells you the different variations of everything. Say you have a 4.5 foot here, you go around divided by 1.5, that equals 3, and 1.5 times 3 equals 4.5, and it just does that. Here 3 divided by 1 equals 3, and if you go on around, 1 times 3 is 3. It just, I don't get the practicality of it as much as I get the practicality of this right here. If you remember the basic formula, and I don't see them having it up here, for slope ratio is ratio, which is R, equals horizontal distance divided by vertical distance. Slope ratio equals horizontal distance divided by vertical. Horizontal distance equals ratio times vertical. Vertical distance equals horizontal distance divided by slope ratio. Can't go wrong. If you know them, you just plug it in. If you know your ratio is like 4 to 1, right? You'd put a 4 here. If this was a, what's an even number? If this was a 2, what would that be? 4 times 2, that'd be 8. So this is probably one of the more useful tools that you'll come across in grades. And at some point when you use it a lot, this will be in your brain. You won't even need, I used to carry a sheet of paper early on in my days when I was checking grade that had this little circle on it, because I knew, if I had this ratio, I would have to know, and I had this fall or rise, I would have to know, I'd have to find this. I'd have to know that horizontal, because when you get back to a slope, I can't get to one here. When you get back to a slope, you need to know where the top of the cut is, horizontal distance to where that toe is. When I get to this next section, let's see, this is a little bit of explaining stuff that probably is in your book. Here's one more, isn't it? What is this? What are we looking at here? Yeah, I'm skipping the percent. How can I do that? We don't want to skip the percent. Here's the percent circle. Notice the difference in percent here. See, it's got percent here, and this is ratio. Horizontal distance is in the top. Percent vertical is in the top. The percent or gradient, like percent grade, it's in the bottom where the slope usually is. The vertical distance is down here in this quadrant when you're calculating ratio, but the horizontal distance is here when you're counting ratio. So this actually is what's called the invert of this. In this one, you have your horizontal distance divided by your vertical. In this one, you have your vertical divided by your horizontal. Same thing goes here. It has all of these variations, but all you need to know is any two of these to calculate the percent grade. So here, this one is a 1%, calling that slope. But here we know the percent, and we know 100 feet. So 100 feet percent, let's see, what do we not know here? I'm not going into this right now. But this gives us, we have a horizontal of 100 feet, and we have a percent slope of 1%. So if we put 0.01 here and 100 feet here, we would have 0.01 divided by 100, equals 1%. No, we got that. That's not what I wanted to do. Let me see what they're doing. Use the percentage formula to calculate the change in elevation of a pipeline from A to B. Here's A to B. From A to B is 100 feet, and the pipe has a specified slope of 1%. So you have to have this percent of slope. So it goes in this quadrant, 0.01. Now, the other thing is you have, do you know what can you find your vertical with having 1% and a horizontal? Let's see where horizontal goes here. If your percent slope is 0.01 and your horizontal, your vertical is going to be, I put in the wrong numbers a while ago, 0.01 times 100 equals 1, your vertical. In other words, from this elevation to this elevation is, I think they made a mistake. No, 301. There it is, 301. No, it's not. The inlet and the outlet show to be even. And I can't explain that right now. I don't know why. Because your vertical would be 1 foot. In other words, if this was an inlet and it was gravity flow, this would have to be 1 foot, 1 foot lower. And these are actual elevations, so this would be 301 feet above sea level. This one would have to be 1 foot lower. And that just may be a mistake on the plans, but there's no doubt in my mind that to prove it, divide the percent of slope into the change in elevation. The percent of slope into I don't talk like that. By 0.01 divided by, well, if you divide that, you get 0.01, and that multiplied to 100 is 1%, and that's what they're calling for right there. No, that's 0.01%. 0.01%, not 1%, 0.01%. So that's the deal. That's what I'm looking at. 0.01% is times I just can't see that right there. If you got gravity flow, I think that 1% is written in decimal as 0.01. Uh, I can't argue that. And there it be right there. Now 100 feet horizontal is written as 100 foot, and it goes right here. And if we want to know the elevation here versus the elevation there, there's only one way to do that, and that's to take the 100 feet and put it here, and 1% is 0.01, and we got to put it here. And if we're going to do that, we're going to end up with a foot vertical difference. And I don't know if it's a misprint. I can't give you that answer, but I know that if this is gravity flow, then it's got to be going down. That's all there is to it. Here's, they did it 0.01 divided by the 1 foot change in elevation. 1 foot divided by 0.01. Is that checking my answer? Yeah, we're right. It's just this one's got to be that's a misprint. I'm sorry, I don't see it written anywhere else though. Here's one. We'll give them another shot, or give us another shot. What's the elevation here if this elevation outlet is 298? So we got 300 foot. That goes there, 300 foot. And we got, that's 0.15%. So that's, what is that in decimal? That's what's happening here. I know it's not 15.15%, 1.5%. That is 0.0015 times, no, not that many zeros. Point 0.0015 times 300. Couldn't find it. That gives me a vertical of 0.45, but it doesn't give us an answer. Oh. So it's going to be plus 298 equals 298.45. But it's not telling us. The outlet, well, it's at least it's different. You add that 0.5 we got to it. And this one's not doing it though. I ain't getting it. This one leaves us room to calculate it. And when you find that 0.0015 multiplied, that goes, that would go here, 0.0015 would go here because that's the percentage, and that's here, and we got 300, and you multiply 0.0015 times 300, you get 0.45. That makes sense. And So that's the change in elevation. If this is true, then this up here is 298.45. I'll take them to the bank on that. I'm not sure what they did up here, but this is not going to be true. If one of these is higher than the other one, it's just not going to be true. This one leaves us room to do it. This is just kind of a pretty good little deal down here to read. If you're confused, we're going to do this some more, so don't be, and you'll have plenty of exercises. If you have questions, uh, be sure and shoot me an inbox or an email, and we're not through. Got a little bit more. We'll see what this says. Most earthwork is rough grading, and that means it's required to bring the graded surface to approximate elevation. I wanted this for you to be sure and understand. Subgrade is the surface of compacted soil on which some other imported material, such as concrete or asphalt, is to be placed. The subgrade elevation would equal the grade to the finished surface minus the thickness of the paved surface. This is important. We are concerned with subgrades, so if the surveyor gives us finished grade, to find our subgrade, we've got to go deeper than the top of the finished grade. We got to go through the thickness of the asphalt or the concrete. So if it says cut 1 foot uh, from to finished grade, we gotta, and we have a foot of asphalt, we gotta go 2 foot. That's where our cut would be. We'll get more into that. Uh, this is telling you that on a highway, your tolerance is 500ths, and on most, I can't find where it's at. Yeah, on most like house pads and things like that, it's 1/10, which is a whole is not quite as tight as that is. Blue tops, we'll talk about them as we go along. And blue is finished subgrade, red is finished grade. And I think I'm gonna shut her down right there. Let me check, go back to the module right quick, and let me see what kind of oh, here, this is the deal. I want this to be in the video. This is something that we've built, put in here, and it's supposed to be printable. So here, the first thing we're looking at is the formula to find percent grade. And this, you take this stuff to the bank, I promise you. Somebody was a little screwed up on that other stuff. Could have been me possibly, but nah, not as we got that far. Once I have this, I'm down with it, you know. So the percent grade equals the vertical divided by the horizontal times 100. Why do you think they put that? Because these, we're looking for percent, not decimal. Otherwise, your vertical is usually going to be a much smaller number than your horizontal. Multiply that, decimal times 100 gives you a percent. And the slope ratio, no matter what the situation is, as long as you have at least known two of these three variables, the horizontal, the vertical, or the percent grade, if you know two of them, you can find the other one using this little guy right here. So hold on to that, print if it'll print. If not, just draw it and keep it with you. Especially during a test, you're going to have some little quizzes that give you uh, it'll give you a ratio and say it has a vertical distance of this. Tell me what the horizontal distance is. So be sure and put that in your pocket. Stay in touch with me. Let me know anything you're doing that you have any questions with. If we need to go back through this, we will, but we'll probably, I may go through a test with you put it up tomorrow, maybe not all the way through it, but uh, if you're struggling with the little quizzes, let me know. Most of the questions will be like you have a slope with a ratio of 2 to 1. It has a vertical distance of 4 feet, and then it'll say what is the horizontal length, and it may put it into what we used to call in grade school or junior high uh, 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 a reading thing, a scenario. You know, you got a pipe that's at elevation so and so, and outlet like we did a while ago. So find the difference in your elevations, and that's going to be your vertical. Uh, you'll be given the percent and the horizontal, and or maybe you'll be given the percent, and you can find uh, that difference in your elevation is given. And if you have the percent grade or the ratio, you can find the horizontal by using these little circles. And with that, I will shut her down for now.